So if you recall feature standardization, so imagine if you're given a data set like this, which is written as a table, and let's assume we have each data point xi, which is a d-dimensional point, and let's assume we have d features, f1, f2, so on, fj, and so on, fd, right? So xi belong to a d-dimensional space, right? So given each feature like this, remember, so let's assume this point is xij. So xith point, jth feature value, right? So if you remember column standardization or feature standardization, what do? We transform each point xij as, so this is the modified point. We modify it such that from xij, we subtract the mean of this feature. So we take all of these values, we compute the mean of this feature or this column, and we also compute the standard deviation. The sigma here is not the sigmoid function, it's a standard, it's a standard deviation for this feature, right? So remember, this is called standardization, right? This is called data standardization, or very specifically, it's also called as column standardization or feature standardization. So remember, in k nearest neighbor, since we use distances between data points, we said that each of your features could be in different scales. We showed an example where one feature could be in one scale, the other feature could be in another scale. And we said wherever we are using distances, we need to standardize our features. We need to standardize our features using this transformation, right? This is your standard feature transformation that you have been seeing from exploratory data analysis onwards. It's a very, very old technique that we learned very, very long ago in this course, right? So even in logistic regression, it is mandatory. It is important. It is compulsory. It is mandatory or compulsory to perform feature or column standardization. Because look at it, what are we computing effectively? Given a hyperplane pi with a normal w, we are computing distances from these points, distance from a point to the hyperplane, right? So here also we are using distances, and we know that if two features or if multiple features are on different scales, right, the scale of the feature could impact your result, and hence we standardize our features. That's the whole reason for standardizing a feature. We saw the example even when we were learning k-nearest neighbor. So just like k-nearest neighbor, even in logistic regression, it is mandatory or it's compulsory to perform feature standardization before you run your model, before training your data, before training on your actual data, on your data D, right? You need to perform feature standardization always. Oftentimes in literature, feature standardization is also called as mean centering and scaling. So you'll keep hearing this term a few times, mean centering and scaling. So whenever somebody says mean centering and scaling, it means nothing but column standardization or feature standardization. So what does this mean? See, because you're subtracting from the mean, this is sort of like centering with respect to the mean, and you're scaling it, right? So this part is called mean centering. This subtracting of every data point from the column mean is called centering, and dividing it by the variance or by the standard deviation is called scaling. So in some textbooks or in some video lectures, you'll hear the word mean centering and scaling. It simply means data standardization that we saw earlier, right? And just like other techniques like logistic regression, other techniques like k-nearest neighbor, logistic regression also, it is mandatory or compulsory to perform feature standardization, because effectively what we are computing is distances, and distances could be impacted by feature scale, by the scale of the feature, by the feature scales, and hence by doing this, all features will be brought into the same scale.